Welcome to solverfy.
For this problem on the topic of oscillators, we are told that a block of mass 4.648 kg, which is resting on a smooth surface and attached to a spring with spring constant 142.7 Newton per meter, has a bullet fired toward it where the bullet has a mass of 7.87 grams, and we notice that the block or the spring compresses by 9.46 centimeters after the collision. We are asked to use this information to find the speed v of the bullet. Now, if we assume that the collision of the bullet and the block is so quick that there is no significant motion of the large mass or spring during the collision, then linear momentum is conserved. The speed that the combination has right after the collision is the maximum speed of the oscillating system. Then the kinetic energy that the combination has right after this collision is stored in the spring when it is fully compressed at the amplitude of its motion. So if we look at first the conservation of momentum, the momentum before the collision must equal the momentum after the collision, which means mv0, where v0 is the speed of the bullet, must equal the momentum when the bullet and block are embedded. The bullet is embedded in the block, so it has total mass m plus capital M, where capital M is the mass of the block, times the maximum speed of the oscillations v max. This means that this maximum speed of oscillation v max is equal to m over m plus capital M times v0. Now, that was the conservation of momentum. We can now apply the conservation of energy, and we know the initial kinetic energy, or the total kinetic energy, half m plus capital M v max squared, gives us the maximum kinetic energy of the oscillating block and bullet system, must equal to a half Ka squared. That's the maximum elastic potential energy at the block's amplitude of motion. Now, using the expression for Vmax from above, we get this to be a half m plus big M times m over m plus big M times V0 all squared is equal to a half Ka squared. So we can make V0, the speed of the bullet, the subject of the formula, and we get V0 to be A over M times the square root of the spring constant K into M plus capital M. These values are all known, so we can use it to find the speed of the bullet. So the amplitude of motion is 9.46 centimeters, or 9.46 times 10 to the minus 2 meters, divided by the mass, 7.87, this is the mass of the bullet, times 10 to the minus 3 kg, times the square root of the spring constant 142.7 newtons per meter into the total mass, which is the mass of the bullet, 7.87 times 10 to the minus 3 kg, plus the mass of the block, which is 4.648 kg. And so computing this, we get the speed of the bullet before it strikes the block to be 309.8 meters per second.